time to do a little more critical points, inflection points, that sort of thing, and also graphing. So you should be able to see it on your calculator too, but to be able to look at these things, we want to take a look at the first and second derivative, more number lines, getting you used to doing that. Pull out the common factor, it makes your life much easier. Set the derivative equal to 0. Once in a great while you get undefined, but mostly it's just when it's 0. Let's see, does this factor? Of course it does. Okay, so trying to leave some space for the graphing itself. Let's see, -3 and 1. Plug a number bigger than 1 in. Let's see, we get positive, positive, so positive. That means it's increasing to the right of 1. We've got critical points at x equals -3 and x equals 1. Pick a number in between -3 and 1, 0. Get positive times negative. Okay, so it's decreasing between -3 and 1. Okay, pick a number to the left of -3 and you get positive times 2 negatives, which is positive. So again, you generally switch signs unless you have a double root. So if you have like x minus 2 squared or x squared or something, then you won't change sign. Okay, so that's, let's see, positive slope to negative slope at f prime. Let me just highlighter that so you can tell. Means f has a max. So in max at -3, when we get around to plotting points, we'll figure out what the y value is. And then from negative to positive, you have a min. So let's just see what's happening. Okay, second derivative takes care of the rest of the stuff. So the only inflection point, possible inflection point, is at -1. And since we have, let's see, to the right of -1, it's positive, negative. So it's concave up to the right of -1 and concave down to the left. And the only inflection point is at x equals -1. Okay. Now for actual graphing, we'll graph the function. If you use the standard windows, you won't see the top and the bottom, because if you trace at -3, you get 14. And if you trace at 1, you get -18. So in order to see this properly, you need heights, not x's, but heights that get up to 14 at -3 and, inflection point, and then, yeah, so -18, positive 14, all right, whatever. At -1, we have a change in concavity. So notice it's concave down, at least as to the left of -1, and then concave up afterwards. Okay, looking at the graph of f prime. If it's a graph of f prime, we can collapse it into a one-dimensional graph. The only place that it hits 0 is at 1. So we're below the x-axis. So f prime is negative. Negative height for f is negative slope for f sorry, negative height for f prime is negative slope for f. Let's write that down. So f prime is always going down, but that doesn't mean f is. F is actually going up because f prime is above the x-axis. So f is increasing for x less than 1. And f is decreasing for x greater than 1. F prime is decreasing all the time. Okay, find the critical point. Let's not say crosses, because critical points are less fussy than inflection points. Okay, so if we draw a little number line for f prime and collapse this into a one-dimensional thing, f prime is below the x-axis until negative 4, and then above from negative 4 to 2, and then back to being below. So f is increasing between and decreasing otherwise. Alright, next. Find the extremas using calculus. Second derivative test. So let's just, let me show you what the second derivative test is. You start the same way. Find the critical points. Okay, so we do not set f double prime equal to 0 for the second derivative test. What do we have? We have x equals negative 2 and x equals 2. For the second derivative test, what we do is we look at concavity. Okay, and then okay, so negative concavity for a max, and people, that's a little counterintuitive because you would think plus would be a max, but no. Okay, so the extrema are at negative 2 comma something as points, it says, so we'll do points. And then we test to see whether it's a max or a min by saying f double prime. Okay, what is f double prime? 6x. Okay, f double prime of negative 2 is 6 times negative 2 is negative. And that means we got a max. F double prime of 2 is positive And again, if f prime is 0 and f double prime is positive, then we have a min. Plugging it into the calculator, we see that yes, indeed, the max is a higher point and the min is at a lower point. What a surprise. Okay, how do you do these? Limit of f of x is 1. So they flatten out. Those are terrible D's. Okay, so what do we do? Let's see. I needed to level off to a height of 1 on both sides, so I'm just going to draw in a dotted line of 1. Going up between -2 and 2. Flatten out at 2. Concave down between 0 and 3, and then not concave. So let's see. I need to be going up, concave down until 3, and then leveling off, changing concavity at 3. So. Okay, flat at 2, going up between -2 and 1, let's see. Okay, and then it says going down after, let's see. How do you make it go down? Well, again, it's not, going down is not going down backwards, it's going down forwards. So, going down. Okay, well, there you go. That's lovely. Let's just take a look at this. F of x is x to the 4th plus c x squared plus 1. What's f prime? And then it talks about inflection points. So let's deal with f double prime. So notice equals 0. This since it's x squared, you can't really do an inflection point if c is positive. So if c is negative, there are inflection points. Let's see, goes through the origin and then bounces And in fact, there's an inflection point at plus and minus something. So concave up for a while, concave down, although I drew it badly, and then concave up again afterwards. So concave down, concave up. All right. C equals negative 1.6. Doesn't actually have a min, it just flattens out, but it does have the nice changing concavity, so. Whereas at C equals 0, you have something that looks sort of like this with no changing concavity. Okay, well, there you go.